The derivation sheet serves as a bridge between the rigorous index notation of vector calculus and intuitive geometric visualization. It grounds the mathematical proof of the BAC-CAB rule, which uses the epsilon-delta relation to simplify nested rotations into dot products, within a structured framework defined by two key diagrams: the state diagram and the sequence diagram. The state diagram, a roadmap of learning. The state diagram provides a visual roadmap for computational vector dynamics, outlining the progression of the conceptual states a user moves through to master the identity. Initial state, the vector sweep. The focus is on fundamental geometry using unit vectors, where the user observes how the resultant vector is pushed and pulled by components while remaining trapped in the BC plane. Interactive state, efficiency optimizer. The interface transitions to include a computational cost display, shifting the focus toward the mathematical simplification that occurs when vectors become perpendicular. Universal state, vector tug-of-war. The final stage moves to non-unit, variable length vectors, proving that the identity is a universal algebraic truth rather than a unit vector trick. The sequence diagram, a blueprint for interaction. While the state diagram outlines the what, the sequence diagram details the how of the interaction between the user and the visualization script. It breaks down the specific visual triggers and transitions. Dynamic rotation. It tracks how rotating vector around the z-axis causes the red and green ghost vectors to oscillate in length along the directions of vector B and vector C. Event-driven vanishing. It sequences the vanishing event in Demo 2, where the screen simplifies visually as a dot product becomes 0, corresponding to a drop in computational operations from roughly 30 down to 7 to 15. Real-time scaling. In the final sequence, Demo 3, it highlights how adjusting the magnitude of vector causes the components to scale proportionally in real time, with a thick black vector acting as the explicit resultant. Together, these diagrams transform the abstract Levi-Civita symbol logic into a cohesive narrative where the user can see, calculate, and verify that the final cross product is always a linear combination of the inner vectors B and C.